let's see, so, it's page 35. Number 11. It's the one that says, on the day of the last presidential election, ABC News organized an exit poll in which specific polling stations were selected and all the voters were surveyed as they left the premises.
And it says the polling stations were selected randomly?
So that step is a part of this process.
Okay.
So what does it sound like? The polling places are already kind of separated into groups, obviously. It's this polling place, that polling place. And they took everybody from some of them. Yeah, good. Cluster. 11. So 11 would be clustered. If they would have taken a few people from each, that would have been stratified. Cool. I like it. Cool. So the word randomly, they've got to select their clusters randomly, the ones that they actually pick from, or else it would possibly fall into that problem like they had in Iraq, where they picked the neighborhoods for a specific reason. Yeah. 15? 18. Oh. So in a study of college programs, 820 students are selected from communications majors, so many from business majors, so many from history majors. Now this is a really good point of discussion, because obviously when you're first learning stuff from a class, it's going to be the basic idea of those things. Now, if you go out and you start taking samples, you can actually mix some of these ideas. This sounds like it's a little bit of a mixture, because I'm sure there's more than just those majors. Unless you're a very specific college where you only teach communications, business, and history. It's a very weird mix, but so you could argue one of two things. It seems that they're pushing for stratified because they've taken a few from each major, but it's not all majors, I wouldn't say. So it seems to be a mixture of cluster, where you randomly select groups, but then it's a little bit stratified because you only take a few from each group. Does that sound right? Now, see, I never want to confuse the issue overly much, because when you first learn something, you learn the basics. But you can always take the basics and make them a little more specific to what you need. You don't have to necessarily fall into one or the other. You can mix stratified and cluster a little bit. So for that one, I can actually see you answering either way. Yeah. They're kind of pushing it towards stratified the way they've set it up. Yeah. Does that make sense? That's why I asked you to explain yourself on the test, because there's a way that I have in mind, but I'm like, I didn't even look at it that way. That would actually work if you explain yourself well enough, yeah. Always. So, like today, I'm hoping at least chapter 1 homework has been turned in or will be turned in. I don't think I've gotten, honestly, any homework at all, so I'm a little worried about that. So you can always turn homework in.
Would you mind
always.
Number 12 as well?
Real quick. But officially, today I'd say up through 2, 3, you might be able to have started on, but we kind of officially ended 2-2 and 2-3 last class. We did that little handout worksheet thing. So if you're done with that by Monday, you're actually on track. Is that cool? Last time, on Monday, we finished out chapter 2. So on the following Monday, if you have that homework done, you're good. You always have until the day of the test if you need more time. But I'm trying to give you a way to know if you're on track or not. Yeah?
Will you be posting the chapter 2 homework on Math Excel?
I will. So anybody on Math Excel or my Math Lab, just if you don't see it, just send me an email. I just need to get in there and do it. Yeah. Yeah.
So then just come in for the homework and video, like at the end of the
So normally at the beginning of class, it's a good idea to slap that bad boy down, or as you leave, bring it up, slap it down. I'd love to get some homework so I can start looking at things. I don't know, except for the few people that have come to see me in my office, I have no idea how you guys are doing, because you all have really good poker faces about it. Y'all understand? Yeah. Yeah, so I don't know. I need to see the work to really see what's going on. Yeah.
Like I'm kind of having difficulty understanding like the next chapter 2.2 when it goes to like cluster midpoints and stuff. Or,
Oh yeah.
class midpoints.
Class midpoints, yeah.
Boundaries and class width and stuff.
The thing about midpoints, I didn't really discuss midpoints too much because I want you to get really familiar with boundaries and limits. But midpoint is kind of a really nice way around that. So if I had classes like this, we had some classes like that before. What would the boundaries be? Remember we did one like this last time? Negative 0.5, 8.5, 8.5, blah, 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 blah. But what would so those are the class boundaries, and then you can graph it based on those, negative 0.5, 8.5, blah, blah, blah. But what would the midpoint of this first class be? What's the point that's right in the middle? 4. So you could have a bar like that, or you could do a bar with right in the middle, which makes sense because it's the midpoint. So 4 kind of defines that bar. And then the next bar up, what's in the middle of those? 13, because 4 away from 9 and 4 away from 17, so 13. How do you find the middle of any two numbers? Add them, divide by 2. You find the average, right? What we call the average, which is actually more officially the mean, which we'll talk about today. Is that all right? So that's what class midpoints are all about. So on a couple of problems, they give you already a setup, and you have to identify what the boundaries are, what the midpoints are, and so forth. That's what they mean when they say midpoint. It's exactly what it sounds like it should be, the middle of the class. Cool. So if I had a funky setup class, 11.42 to 12.89, 12.9, oh God. How do you find the midpoint of that? Like we just said. Add them up, divide by 2. You don't have to sit there and rack your brain. I like it. Is that cool? So, I'm not going to do this a lot, but chapter 1 I said was, some of it was on your shoulders to go through. And that's why I wanted to send that out before the semester even started. So there are several little things in there that I didn't even talk about. It's just definitions. You should be able to look it back up and kind of read through it. But obviously if I don't get any questions about them, I'm a little bit worried about how much homework is being done. So somebody should have a question on this thing. Okay. Any other questions from chapter 1 or 2? All right. I'm still an optimistic fool. So this means that you're doing it and it's going fine. All right. Just to let you know what's going to happen here pretty soon. And I know our first test is on the 20th. February 20th is test 1, but because February 18th is a holiday, it kind of makes things a little bit weird. So what's going to happen is next Monday, I'm going to give you a practice test. All right? We're not going to do it in class. It's something you can do on your own. So I'm going to give out a practice test Monday. And then on that Wednesday, we're not going to do anything new. We're just going to focus on review. We'll have the answer key for the practice test. We'll review. We'll talk about a formula sheet. We're actually going to get some formulas today. Next Wednesday, review. If you don't want to do the practice test at all, if you want to just take it and turn it over and use it for scrap paper and never look at it, that's fine. I don't care. You have to turn it in. I give you the answer key anyway. So you can use it however you want. It at least shows you how I normally set my tests up. For those of you who have no idea what I do, which is most of it. All right, cool. So that's what's going to happen. Let me think. Did I just mess something up? Yeah, because the test, February 18th is a holiday. And February 20th is the test. So I said things kind of get messed up. Cool. So any questions on that schedule? All right. So today we're going to get into chapter 3. And actually, I want to say something real quick. Let me see if I want to put it up here or not. I was, as I want to do, I was listening to NPR, and they were talking about a subject that's not very, good to talk about necessarily, but it's certainly good to get data on it so that something can be done. So right now, does everybody realize there's a conflict going on in Syria? Yes. Okay. So maybe more than others. This is an example of what we were talking about the other day. There was a problem about motorcycle helmets and who couldn't testify, and of course the people that passed away were in a coma or something couldn't. So what's traditionally done with rape in war is to discuss it with people after the war is over, because it's difficult to get in and get to them while the war is going on. But of course, if you do that, very likely what's happened to these people is they might have died or been put somewhere else or silenced in some way. So it's just the realization of something in the real world that you have to be careful about your sampling methods. If you go in after the fact, you're never going to get an accurate picture of what was happening. The problem is, and this is where it's getting kind of nifty, they're using social media and other ways to try to get a feel for what's going on. And well, maybe I could put it up. They have a, let me show you this real quick. So they have, let me get a little more specifics while that's coming up here. Yeah, they're using reports on Facebook, Twitter, YouTube, and of course, the problem they're trying to account for is getting a more accurate and actually more of a live update on what's going on. What kind of creeps in to make people a little wary of that way of doing things? If you're using Twitter and Facebook and other social media,
It's not accurate.
it might not be accurate. So of course, then you could follow up, but you're getting the data now, and then you can maybe follow up when it becomes easier to follow up. So in a way, if you do both parts of that thing, it makes it easier. You don't lose people, but you can also verify the accuracy when it's possible to do so. So as long as people understand that they're not necessarily trying to say that this is all exactly what's going on, what they're trying to say is there's a problem with the way we normally collect data. This is an attempt to improve that. And an attempt to figure out how to use it. Oh yeah, I remember. It's like forever. Okay, there it is. So this is the NPR website where they talk about it a little bit. This is the map that they've created through their use of trying to track things through social media. So the red circles are where things are happening, and the number inside is the number of incidences reported. So it's just an interesting attempt at improving what's going on. The other half of it is to make people buy into it, to make it believable, trustable data, is the coming in after the fact to kind of verify what they see. So these are kind of things that happen. Twitter is insane. When I first heard about Twitter, you're like, well, it's appropriately named Twitter. But then all of a sudden, it's got all these things to do with things happening in Egypt and things happening all over the world with people being able to get stuff out, the realities of what's going on. It's amazing, really, what it's done. And here's one more possible application. As long as they can make it, people can believe it, can trust it. Cool. All right. I might as well leave that up there because I'm going to use this guy later. I never want us to get bogged down in the ideas of statistics and the calculations and the formulas and forget that this actually is something that's important in the real world. Right? It's not just something we just do here so you can check it off on your list of things you need for your degree. It's actually something that we use all the time and everybody should freaking understand. Okay. So getting into chapter 3. Section 3.1 is called Measures of Central Tendency. Or just measures of center. That's what I used to call it. And there's all different ways of measuring what the center of a list of data is. For example, if I had, I think I gave this example last time. If I had a bunch of salaries, let's say this is in the thousands. This is salaries for people at some company somewhere. So somebody's making 40,000, 42,000, 51,000, 61,000, and then here's the head honcho, boss man or boss woman, making 500,000, which is nice. If you wanted to tell somebody the center of that data, what comes to your mind? How could you tell somebody the center of that data? There should be something, just the way you say that and look at it, there should be like one obvious way to do it. What's the center of that data? I like it. So 51, especially because I put it in
The middle.
I like it. That was awesome. Sorry. But in order, yeah. Sorry. If I would have put it out of order, then you couldn't just say the middle. It's got to have some sense. It's got to be the middle if it's in order. That makes sense. Cool. So 51 is one way to determine the center. What's another way to determine the center?
Average.
Yeah, it's find the average. So can somebody help me out? How do you find the average? All right, so you said, that's right. So we got to be a little careful when we say average. Average actually means more things than we mean. So we call it the mean in statistics. Because we like four-letter words that start with M in math fields. Yeah. So mean, the symbol for mean is going to be one of two things. So either it's going to be for a population, it's going to be, you're going to like this, it's going to be mu. That's not an M. But if you make an M, it's okay. So to make that symbol, you just start like that. So it's like a U with an extra leg in the front. And it's pronounced mu, like a cow with an accent. So this is Greek letters, mu. That's the population symbol for mean. So if I have a population and I get the mean, that's the symbol I can use for it. And the sample, pretty much in general, population stuff very often is Greek letters. Sample stuff is our letters. So here the sample mean would just be X bar. How are we doing so far? All right, no matter if it's a population or a sample, what do you do to find the average, what we now know is called the mean? Like you just said, you add them all up, divide by how many there are. So that's how we say it in English. In English, to find the mean, add them all up, and divide by how many there are. So in math, of course, math people don't necessarily, they're not scared of words. They just want to be more efficient with the way that they put stuff. That's why we make up these symbols and formulas. So add, we use the symbol Greek letter S, which is sigma. Right, so some of you guys looking to move into, transfer to colleges, you might be looking at sororities or fraternities, and you got sigma nu phi and sigma sigma sigma, whatever. So that's where you see Greek letters, and of course a math person seeing that will think, what is that formula for? Oh no, that's a So add them all up, sum. That's the Greek letter S, sigma. And that symbol by itself doesn't make any sense mathematically. Sum what? There's always got to be something next to it. Sum up what? And of course, what symbol would I use to represent all of these data values at once? What symbol do we use in general to represent a lot of different values? X. I love it. So this means add M up and divide it by the number of data points. I like it. So I kind of legible. The book uses a big old N. I don't understand why. Just N in general means the number of things you're working with. The book uses a big N. Why? Because it's the population. Bless you. So for the sample, what's going to be at the bottom? A little n, because it's just the sample. So on the bottom there's a little n. On the top is the same thing. And then add them up. How are we doing so far? Is that cool? So let me get a little bit more specific real quick. So if these are my data points, what is this? So these are my x's. What is that? Don't overthink
Your
it.
sample.
Oh, it's 694.
Yeah, it's whatever those added together are, right? Because that's what that says to do. This is the add them up. So what do you get when you add them up? 694. Cool. Well, how would you do this? This is a semi-evil question, actually. You would not square 694. That's not how you would do it.
With each number squared.
I like it. This would be 694 squared. Do you remember that thing in algebra where they did this to you?
Yes.
And students are, you square, you get positive. No, it's not. You do square, you get positive. It's just a negative on that one. So it's still negative. And that, of course, is the positive one. Here, this is saying, I square the x's and then I add them up. This one says you add them up and then you square what you get. So how would I start working on this? What would I have to get first?
X squared.
I'd have to get a list of x squares. Cool. So we're going to run into these formulas. They're going to have this symbol running around, and next to it is going to be something it wants added up. You have to find those first before you can add them up. How are we doing? So if I have this list of data, 40, 42, 51, 61, 500, and I want the sum of x squared, my sigma gets worse and worse. I need a bunch of x squares. So 1600, 1684. Somebody help me out. So at some point this is going to run out.
2601.
Thank you. 3721.
Yeah. You should get the 500.
Cool. And then I can add these up, and that's what sum of x squared is. How are we doing? Doing pretty good. I will show you, I didn't really bring any calculators today, but I will show you shortcuts for this to do with the calculator. You can put list 1 these, and then you can find list 2 to be list 1 squared, and it'll all at once, and that's kind of nice. Good. How are we feeling so far? Is that all right? So we got our first little stats equation.
Didn't you just find all the information with this one in the bar stats? You can get
Oh,
that
hell
back.
yes. Definitely. And I will let you use that, but in the early going, you must show me a lot of stuff by hand. Oh, yes. So if you know something about statistics and you know, like standard deviation is coming up, I will make you do the standard deviation by hand for test 1. Forever after that, I will never make you do it again. You with me? So there are buttons in the calculator, and it costs damn well enough. It better be able to do a lot of this stuff for us. There are buttons in the calculator that will make it spit out to you the mean and the median, and it'll spit out the, we haven't talked about median, and standard deviation, it'll just spit it out at you. And then the calculator passes the class and goes on to get a business major. Yeah, look out there. So obviously, you'll learn very quickly that I am big on doing things by hand to really understand what the hell's going into something. A little black box hides it. You need to see it. So yes, on this homework, I'm going to have to see a little bit of work. Don't just spit it out at me. Show me a little bit of filling this stuff in. Yeah.
I got confused where between the population and sample there's a capital N and a lower.
Oh yeah. I wish they wouldn't do it, but I just want to show you because that's what the book does. N always means the number of things I'm looking at. It shouldn't really change just because I happen to look at a population or sample. But they made it big for the population because
That's the only difference.
that's the only difference.
Okay.
Essentially, they're the same formula. They just have different symbols so that people know if you're talking about a population or a sample,
Okay,
just
now,
by looking at your symbols.
Now on the sample, are you supposed to put the bar over that?
Yes, good. Because X by itself means these data points.
Yeah.
That bar actually kind of symbolizes the average, the mean of those. So if I had another list of data, I'd have to call them the Y's. And then the average of the mean of those would be Y bar. And then Z's and Z bar and however much you want to do. Is that cool?
Yeah.
So when you see a little bar on top of these kind of letters, that normally means the mean of those things. And if you only have one list of data, you're only going to see X bar. Cool. All right, how we doing so far? Is that all right? All right. So that's one way to measure center was the mean. The other way was what you guys already pointed out to me, that looks to be in the center because there it is. It's right in the middle, right? Which, did I actually get this average here? So this is a sample of salaries. So we know that's 694, and there are 5 of them.
38.8.
I like it. So you can tell somebody it's like $138,000 is the center of all the salaries. You with me? So this is, I'm going to come to this company. I'm just applying to this place. What's like the middle salary? Somebody says $138,000. Like, damn, yeah. Well, what's wrong with that? I mean, is that honest? No, because of course that guy just totally takes over. Just sucks the mean up a lot higher than it really should be. So this guy ends up being the more honest answer. And that's the same reason why whenever you see home prices being discussed, they always say the median home price has gone up or down or whatever. You almost never see them say the mean or the average home price, because that inherently that's not fair and accurate. Right? All those homes in La Jolla suddenly throw the whole damn thing off. So the second way of looking at things. So everybody got this stuff here? Let's take this a yes. So one way is the mean. The second way is what's called the median. And the symbol here is X tilde. So you got to be really careful. If I give you a list of data, you have to first make sure it's in order. This one's kind of easy. If I have 5 things, there's obviously something. There's obviously something right in the middle, right? But if I have 4 things, what the hell? I like this. So if I had 8, 10, 11, 14, that's 5, Jeff. Stop. How do you find the median of those? I like it. So to get the middle number, there is no number from the data set that's in the middle. So the only one thing you do is get the middle of the 2 that are in the middle. That's freaking middle. Right? If you take the 2 middle numbers and average them, get the middle of those, that is without a doubt the middle. Right? So if you have an odd number, there's going to be a middle guy. Even number, you average the 2 in the middle. So here you get 10 plus 11. You can just get that, I'm sure. Hopefully. 10 and a half is obviously between 10 and 11. But that would be the median. Cool. No big deal there, right? So what if you had a list of 80 data points? And yeah, it just sounded like I was from the Midwest. 80 data points. Where would the median be? Is it the 40th data point? Look here, how many data points were there here? 4. Where was the median? In between the second and third, right? So is it okay if I say the 2.5? You guys understand what I mean when I say that? It's not the second data point. It's not the third data point. It's the 2.5 data point. All right, you kind of with me? I'm trying to show you a little shortcut for when your list is really big. So 80 data points. To find the median, here's a little trick. To find where the median is, you add 1 to the number and then divide by 2. So look, does it work for 4? If there are 4 data points, add 1, that's 5, cut in half, that's 2.5. That's exactly what we just said. That's where the median is. So if at 80, I add 1, 80 plus 1 over 2. 81 divided by 2 is 40.5. So it's going to be the average of the 40th and the 41st. Are you guys with me? All right, good. I have no idea what it's the average of the 40th and the 41st to get the 40.5th number. Okay, sort of. Maybe. Some of you guys are bored and some of you guys are bright. Okay. So we have mean, we have median. There's one more way to kind of measure center, because those 2 methods, mean and median, what kind of data do they work on? And think back, what types of data have we discussed so far? We've talked about quantitative data and qualitative data. Can you take the average hair color?
No.
Can you find the median name of dog?
No.
No, right? So mean and median, they only work for quantitative data because they both involve, to some degree, adding, subtracting, dividing, that kind of stuff. They have to be true numbers. This third way of doing things, the mode, and again, four-letter word starts with that, it's the one that occurs the most. So if I had a list of dog names, what's the name of your dogs? What's the name of your dogs, right? You know. If I had a list of dog names, I can't average them. The average was blue. I don't know. I can't find the middle, really, because there's no real inherent order to them. You with me? But I can find the mode. I can just see which name occurred the most, if any. Okay, so if I have a list of data, for example, 1, 1, 2, 4, 7. No idea what I made that 2 like that, but what's the mode? 1. I love it. So that's easy. Start off nice. There's no symbol for mode, really, that anybody ever stopped to make. So just write mode. What about here? 1, 1, 2, 2, 4, 7.
1 and 2.
Cool. 1 and 2. There's a tie. So it's what's called bimodal. All right, so the mode, it's bimodal. 1 and 2. What about if it's 1, 1, 1, 2, 2, 4, 7?
1.
Yeah, there's a clear winner. I don't care if there's a couple 2s. There's 3 1s. It beats. It wins. So the mode here would be 1. Right, mode is awesome. Mode makes the most sense. And of course, if there is no mode, you just say no mode. Cool. So you can have 1 mode, 2 modes, trimodal, polymodal. It's crazy. Right? So however many freaking modes, you just list them all out. Right, how are we doing so far? It's not too bad. This is kind of a nice way to step into statistics math. Right? This is nothing too major yet. So of course, I mean, you know, like the example I gave earlier, if I had my dog's name is Skippy, and this guy's dog's name is Fred, and this guy's dog's name is Skippy, and, you know, then obviously Skippy would be the mode so far. Right? So it works on qualitative data. One last thing, it's not really used very often for this purpose, but it is a valid way to measure the center. It's called a mid-range. Does anybody remember what the range was?
Y values?
I like that. That's from domain and range. I like that. But in statistics, the range.
It's the highest and lowest.
The high minus the low. So mid-range should be the middle of the high and the low, and this is where things get freaky. The range you subtract to see how far they are apart. The mid-range, you have to get the mean of those. You have to average those together, which means you have to do what with them? Add them. And people always subtract because you get so stuck with that idea. But the mid-range is basically, and there is no symbol for this again, is the high, wow, plus the low divided by 2. So the mid-range for this data, in fact, let's look at this data right here. The mid-range, what's the highest? 7. What's the lowest? 1. So the mid-range would be 4. What's the median? Yeah, there's 6 data points, so you have to take the 2 in the middle. Well, the 2 in the middle happen to both be 2. That's the easiest average ever, is freaking 2. Cool. And what's the mean?
Yeah.
I know, well, you know, I'm a math teacher, man.
Believe it or not.
I gotta show off every night, that's all I can do. 2.83. Can't duck a ball, I can't play guitar, but I can be a Rain Man every now and then. Tom Cruise. Dustin Hoffman, even more important. All right, is that cool for those? So those four, did I leave one out? Oh yeah, the mode. What's the mode? Yeah, we already did 1 and 2, yeah, cool. So those four things, they're going to give you a list of data, they're going to ask you to calculate those four things. You do have to show me a little bit of work. Don't go crazy, but you got to show me something. I won't make you redo it if you show me nothing. So why waste the time in the first place if you have to do it again? Silly. I'm not going to worry about the weighted mean. I think I gave you one problem like it though, so I want to show you how it kind of works. And it's not like in a class like this. Let's make it a little bit simpler. Let's say there's a 50% midterm. Let's make it screw it, just leave it like that. 10% homework and a 40% final. Just because. How would you calculate your average at the end? Let's say you got 74 in the midterm, you got a 98 in the homework, and you busted your ass and you got an 81 on the final. Do you just add those up, divide by 3?
No.
Hell no. So your average, your mean, is made of 50% of this plus 10% of this plus 40% of that. So you have to weight each of these values. Right? And we kind of already do that. Watch, if I just had 74, 98, and 81, stay with me now. If I just had those numbers and I said average those, then you would add them all up, divide by 3, right? And isn't that essentially taking, now stay with me. I always explain this a little differently, and I don't think I've ever explained it like this, so let's see how this works. Isn't that essentially taking 1/3 of 74 plus 1/3 of 98? You guys see what I'm doing? I can break them all up over 3, you with me? 1/3 of 98 plus 1/3 of 81. Because in this case, they're all equally weighted. They all are worth 1/3 of the final average. Well, here, they're not. I'm specifying that they have different weights from the beginning. So to get the average here, I would do 50% of 74 plus, where am I at? 10% of 98 plus 40% of 81. And, you know, whatever the hell that is. 49. Wait. Where do I leave out? 32. Somebody help me out.
30 plus 9.8 plus.
Do it again?
It's 37 plus 9.8.
Yeah, that's true. Plus 32.
2.4.
Yeah, 32.4. So then whatever that is. 46, 79. Wait, thank you. So that's your average there. Right, and you're like, come on, dude. Freaking B.
Minus.
Yeah, B minus at most, but hell no, that's still just a C plus. Right, how are we feeling about that? There is one question just like that, where they have the percentages there. That's all you got to do is take the weights, the specific weights into account. That's all you got to do. All right? Because what's the other way to set up classes? Some professors have the percentages, other professors have the points. And personally, I always hated those freaking. Because I'm a math guy, it makes it way too easy. But I don't know. That's basically because of that. All right. So any questions over what we just did? Okay. The last little part of section 3.2 kind of looks ahead a little bit, but you guys remember what you would call this kind of thing?
Normal curve.
Good. So it's a normal distribution. And this is what we expect to kind of see with, if I plotted a bunch of heights from randomly selected men, if I plotted all their heights, I would expect to see this. Not very many really short guys, not very many really tall guys, most of us in the middle. That's one reason why it's called a normal distribution. It has to do with what happens naturally with some things like height and length of fish and weight and all that kind of stuff. And it also happens with grades very often. Not always. I personally don't see a damn thing wrong with my entire class making A's. That could happen someday. Don't get excited. You have to prove it to me. But yeah, I mean, I don't see a damn thing wrong with that. I could just happen to get a bunch of people that kind of understand what the hell's going on. They do great. Well, who cares? That's fine. But you want to, what this really gets at is your tests have to be able to kind of really get people tested out. And if everybody's making an A, your tests are not quite hard enough. You got to kind of, really separate some people out and see some people understand a lot more, some people understand less. But you heard people talk about curving grades. I can remember I already talked about this. We just pick the curve up and move it based on where the grades really are. So C is normally in the 70s. If everybody scored down in the 20s, 30s, and 40s, you might make a C a 30 instead. Kind of move the curve. This is, would you say this is a normal curve?
No.
No.
No, and this is called skewed. This is skewed to the, what do you think?
Right.
I like to the right. So skewed to the left, the tail would just be the other way. Like a comet. You guys know there's going to be a really bright comet this year? Like crazy. It's supposed to be decently bright. They thought at first it was going to be crazy bright. Now it's just going to be decently bright.
When?
I forget. It's not anytime too soon. Look it up. Comet 2013. All right. It's not going to hit us, so don't freak. Send up there Bruce Willis. Everybody else. All right. Another way, the normal distribution, part of what it does, of course, is this is symmetric. Which makes it for an interesting property. Where would the mean, where would the average be in a normal distribution? Be right in the middle. Now I understand what you mean by top, because that's the one that occurs the most. So that would also be, if that occurs the most, that's why it's so tall. Just like a rectangle, the taller is, so that would also be where the mode is. And where would the median be? What number's right in the middle? Well, the same stupid thing. So in a normal distribution, the center, all the measures center agree. You with me? The mean is the same as the median is the same as the mode. They're all in the middle. So it's another kind of nice thing about normal distributions. Okay. Here, obviously, things have been skewed, so they don't all agree. Oh yeah, I do want to show you one thing in here. I might as well show you this. We'll do this again later, but I want to show you right now. If you do put in here a bunch of data, there, okay. So put that in there. If you hit stat calc, and this is what somebody was saying earlier. They know about this one button to press to make this thing do everything. One var stats, because that stands for one variable statistics. I only have one variable that I put in there, whatever those numbers represent. So if I hit one variable statistics, if I wanted to do list 2, I'd have to tell it list 2. But I want to do list 1, I actually don't have to tell it a damn thing. It defaults to list 1. If you hit enter now, what do you know? You know a lot. In fact, you know a few things you don't even really know what the hell they are. You know these numbers. I didn't know how to say that well grammatically. You know a few things you don't even know. So here you know some numbers. You don't even know what these represent. Those are coming up in the next section. You know the mean. You know the sum of the x's. You know the sum of the x squares. You know all that kind of stuff. So be really careful. In the early going here, I'm not going to allow you to just pluck these out. This is a great way to check your work. It's not a great way to do your work. So I just want to do a little preview of section 3.3, and then we're going to head out slightly early. If you knew, how many of you guys know about, there's a website where you can rate, that's the name of it, rate your professors? Yeah. I remember I was on the East Coast, and somebody came around and told all the professors, hey, you guys know about this new website, Rate My Professors? The next day, I looked at it, and several of them had gone in and rated themselves. And somebody wrote, he's the essence of the essence. Dude, what the hell? So, that's one place you can go for obviously possibly biased stuff there. But there's another place you can go where thankfully it costs money now. How many people know about a website where you can go and see grade distributions? Thinking about what the hell you just said. You can actually see, because it's public domain knowledge, you can see, breaks down by professor, what grades they've given out in courses. Now, obviously I have a problem with this in the sense that there are some students who would use that incorrectly, but that's not a reason to not put the data out there. It's up to you to use it correctly. So obviously some people will go to the guy who gives everybody an damn A or B, especially in statistics. And then I get them in the next class and they don't know shit because they didn't really get the grade they deserve, right? Or the guy just doesn't teach anything, he just says, oh, I just have an A. So you gotta be careful, right? But here's the situation to talk about section 3.3. You guys can go try to find that website later.
Google it.
If you knew there were two teachers, and let's say everything about them is pretty equal, they're like twins, and all this kind of, and their personalities are basically the same and all this kind of stuff. But one of them, they both give C's on average, right? All the students earn a C. The mean grade they give is a C. But this teacher gives between B's and D's. And this teacher gives between A's and F's. Right? So this one doesn't want to, I had a teacher that never gave an A. He's waiting for God to get it, and then God would get an A minus. But I'm not bitter about that. And then, you have teachers, of course, that give the full gambit. But this also, they don't want to fail anybody. Like, it's probably my fault. I don't want to fail anybody. Which class would you take?
A through F.
Yeah, so some of you guys would say the A through F because I'm going to bust an A out of this place. And I don't want to take this one where I can't earn an A. But of course, now realize I'm talking about you're at university already. Community colleges, D's don't really work for you, but if you want to transfer those courses. But let's say you're at a university. If you're really scared of this course, you would take the B through D person. Because then you kind of know, well, at least I'm going to pass no matter what the hell happens to me. Right? So just having that knowledge, just knowing they both give a C on average is not enough knowledge to help you make a decision. You need that extra piece of information. How much do the grades vary? Right? You with me? So that's what's getting into section 3.3, which is where we're going to learn what the hell those symbols, those last couple symbols really are, and how to calculate that by hand. Yay. All right. See you guys next time. Yeah, sure. You got homework, please give me. Get a stapler.